The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to today's webinar. You'll learn how Pointwise can help you deal with the typical sorts of problems you run into with CAD geometries when you're building meshes for CFD analysis. We're going to be doing a live demonstration of meshing on a ship hull geometry. I'm Rick Matus. I'm VP of Sales and Marketing here at Pointwise. I'm going to give a brief introduction and cover a few ground rules for the webinar before we get started. First off, our schedule. Live demonstration will take about 20 minutes. During the demonstration, you won't be able to ask any verbal questions, but you'll be able to type questions into the question window, and we'll answer them as best we can. After the demonstration, there will be time for verbal discussion, so if you've got a microphone and you're more comfortable talking instead of typing, you can ask questions verbally after the demo is done. Dr. Chris Sidoroff, our sales engineer, will be leading today's live demonstration. Chris earned his PhD in mechanical engineering at Syracuse University in the area of personal microenvironment analysis. He used GridGen for some of his graduate research, and since coming to Pointwise, he's quickly become an expert in using Pointwise as well. Also assisting with today's webinar is one of our interns, Travis Kerrigan. Travis is a master's student in the Mechanical and Aerospace Engineering Department at the University of Texas at Arlington. He's been using Pointwise for a couple of years, and he'll be doing the driving today. With that, I'll turn things over to Chris to begin the demonstration.
Okay, thanks a lot, Rick. The goal of our demonstration today is to show how Pointwise can help you deal with dirty and incomplete geometries, a major bottleneck in CA pre-processing. As Rick mentioned, I'll be demonstrating how Pointwise can be used to clean up the geometry on a naval ship hull. The actual geometry is the DTMB 5415, a naval surface combatant hull conceived by the U.S. Navy as a benchmark case for the design of such surface ships. The original geometry and details can be found in a variety of locations, so we'll provide links to some of those sources and the geometry files on our website after the webinar. So today we'll be showing Pointwise's facilities for cleaning up and dealing with this geometry. You'll see some of the many tools it has for importing, creating, and modifying geometry. And it has a couple general methods for meshing on the geometry. And the first is something we call fault-tolerant meshing. So fault-tolerant allows you to heal the mesh over faulty geometry, and then you fix errors on the mesh level. The other, called solid modeling, allows you to heal the geometry first and then mesh on the healed geometry second. These two techniques are not mutually exclusive, and they can be used together, and we'll be demonstrating both of these methods today. So while the focus of the webinar today will be geometry cleanup, we'll also include some meshing techniques to help with the explanations. So let's get started. So here's you've already seen it, here's the hull geometry. Fairly innocuous looking geometry. But when we shade it, you'll notice that there are overlapping surfaces just behind the bow region. These overlapping surfaces are going to cause meshing problems, so we need to fix this before we can begin meshing. So to clean up the overlapping surfaces, Travis is going to begin by splitting the long surface hull at the back edge of the overlapping surfaces. Now that it's split, the smaller surface is no longer needed, so he's just going to get rid of it. The next step is to clean up the top edge of the hull surfaces. So Travis has zoomed into that region, and you'll notice that the edges of the adjacent surfaces don't make a smooth edge along the top of the hull. So we're going to trim the surface in this region to get a smooth edge along the top of the hull. Travis is using one of the curve drawing tools in Pointwise to draw curves across the misaligned surface between the points and the adjacent surfaces. And I should point out, he drew the new curve constrained to the existing surfaces. This is important for a couple of reasons. One, because we don't want to lose the original shape of the hull surface, and two, to be able to trim the surface with the new curve, the curve must be constrained to the surface. So now Travis can go ahead and trim the surface with this curve using Pointwise's surface trimming tools. And he's going to, of course, he'll choose to keep the surface patch below the trimming curve. Now that we clean up the hull surfaces, we'd like to close the hull with a deck surface. This geometry will most likely be used for multi-phase CFD calculations, simulating water below the waterline and air above the waterline. So we'll need to close it to the symmetry plane. So we'll just start by creating a Y symmetry plane that will be used to create curves in the next step in the aid of the construction of the deck. So Travis is going to start by sketching curves along the hull edges, and then as a second step he's going to project those curves onto the symmetry plane. So you can see Travis is using the existing surfaces to sketch those curves on, and in particular the edge of the hull. And now that he's done that, he's going to use that new curve and he's going to project it onto the symmetry plane. So you can see the projected curve does not quite match the stern surface so he's going to stretch that new curve to the corner on the stern surface. While this is likely an approximation of the actual deck, this is the best we can do since there's no geometry present for the deck in the first place. So now that we've created curves for the deck on the symmetry plane, we can use these curves along with the boundaries of the hull surfaces to create a three-dimensional deck surface. So just a quick recap before we move on. So we began by using some of Pointwise's geometry modification tools, specifically splitting and trimming tools, to fix the overlap and mismatch hull surfaces. Then to close off the hull, we created a deck surface using some of the curve and surface creation tools, demonstrating Pointwise's ability to create geometry from nothing. So now that we've fixed the overlapping surfaces, we can think about meshing the hull again. So right now all the surfaces visually make up a watertight hull, but there are actually some small gaps between the surfaces. And you can check for gaps between the surfaces in Pointwise by examining the proximity of the surface boundaries. So by moving the cursor over the shared boundary regions, you can determine the gap between the surfaces. In this case, Travis has picked one of the points between the newly modified surface patches to highlight there is actually a gap between these surfaces. It helps to note this gap value. In this case, it's about 0.0002, as we're going to use it for some of the upcoming steps. So there are two general ways to deal with these gaps. So I'm going to use some simple schematics to describe both approaches. So as we know, CAD files commonly have gaps or overlaps, general sloppiness that can be a barrier to meshing. So my schematic here shows 4 surface patches with a small gap between each. So the first method starts by simply creating meshes on the dirty CAD. The meshes at this point have the same gaps and overlaps that CAD does. So using the mesh merging tools in Pointwise, the last step is to fix the mesh gaps and overlaps. And we call this method fault-tolerant meshing. Fix the errors on the mesh level. So just before I explain the second method, I should point out the use of red and blue for the internal line colors. In a couple of the operations in Pointwise, you'll encounter red and blue curves denoting their status. The red curves, seen in the middle picture here, we call them lamina, indicate internal curve. The internal curves is used by only one surface, indicating there is a gap present between the surfaces. Blue boundaries, we call them manifold, indicate the internal curve is used by 2 surfaces, and this means that there's no gap or overlap existing between internal surfaces. And this is ultimately what we're after. For the second method, we take the opposite approach. So starting with the same sloppy CAD, we now heal the geometry first. You can see now we have blue internal curves indicating healed up geometry. So once these gaps and overlaps have been fixed, we then create the mesh on the healed geometry. This way, when we create the mesh, it is automatically watertight. And we call this method solid meshing because watertight solid models are what facilitate this approach. To demonstrate the fault-tolerant meshing method, Travis first creates meshes on all the surfaces, and then he's going to use a tool to check if the internal grid curves are shared by more than one surface. So like I discussed in the schematics, when the internal curves are blue, 2 surface meshes share their grid curve, and this is what we want. And we see this where Travis has his most right now. But where the internal curves are red, a grid curve is used by only one surface mesh, indicating a gap in the grid curve is not what we want. And we see there are 2 regions where the internal grid curves are duplicated because of gaps in the geometry. and Travis is going to fix them by merging them together using a tolerance larger than the gap tolerance that we've seen previously. And you can also use the table in the top left-hand corner to indicate free and or else we call them laminar and manifold curves. And this is really the key concept in the fault-tolerant approach. Don't worry about the gaps and the cracks in the surfaces because we can heal them on the mesh level. And in fact, Pointwise is so flexible meshing on faulty CAD, you can even mesh where there is no geometry. A very useful concept when you have missing surfaces and you don't want to fill in all those missing pieces. To demonstrate the solid meshing method, we're going to back up a couple of steps. So in contrast to the fault-tolerant meshing, we're going to fix the geometry first and then mesh second. So Travis first picks all the hull surfaces, and then he's going to use the model assembly tool to heal the gaps. So the model assembly process is very similar to the grid merge process. We're trying to make sure all the internal curves are blue, shared by two surfaces. In this case, Travis again entered in a tolerance larger than our gap tolerance, and we can see all the internal curves are blue. So just before I move on to meshing this, just a quick clarification. So solid models in Pointwise are not actual physical geometry entities, meaning they do not modify the underlying surfaces. They're simply glue between the surfaces to let the mesher know there should be no gaps between those surfaces. So now there's a new entity type called a model, and now we want to mesh in the model instead of the surfaces because the model contains the information necessary to make the mesh watertight. And just to confirm the mesh is watertight, Travis uses the merge tool again, and we see now all the internal curves are blue. So just one thing to note here is that a single mesh is applied to each surface in the model. So an additional concept I'm going to introduce along with models is the notion of a quilt. The quilt are meshing regions on the model, and by default there's a one-to-one correspondence between the underlying geometry surfaces and the quilt. So Travis has shaded the model to indicate the colors of each quilts. So we can use quilts to control surface mesh patches. So for example, along the side of the hull in this case, we can join the quilts together to simplify our surface mesh. And we can see now the color is updated to reflect that. So Travis is going to mesh. He's going to mesh the new model that has the joined quilts. So if we, and now he zooms in, and we can see how the quilt dictates the resulting surface mesh patch. The surface mesh now straddles the underlying edge between the surfaces. So just a general tip about joining quilts is that you only want to join them across smooth edges. Otherwise, if you mesh a quilt that's been joined across a sharp edge, the interior mesh points will not be able to change with the sharp curvature. So now that we've seen the differences between the two methods, the question you might ask is, when should I use one or the other? So here's a list of the key items that may help you decide. So fault-tolerant meshing is generally best suited if you only plan to use the geometry once or just a few times. You want to get to the final mesh as quickly as possible and don't plan to analyze the geometry very frequently. Another area it's suited for is if you have a few localized problems in your CAD that you don't want to fix, or maybe that's not even fixable, but you don't want that to stop you from meshing. And then the last concept, something I use very frequently, is the ability to mesh where there's no CAD at all. And I use this approach for far field boundaries and external flow problems where I just need a simple box shape. So as you'd imagine, solid meshing's benefits are somewhat the opposite to fault tolerant. You plan on analyzing your geometry many times, and having a cleaned up geometry is going to make it easier to do that. If you have lots of problems kind of all over your CAD, it's generally best to fix them first. So again, solid meshing is maybe the better approach in this case. And the last, and probably the most obvious benefit to solid meshing, is when a solid model is already present in the CAD file. And this is the best case scenario because there's no need for cleanup. You can go straight to a watertight mesh. And a final but really important point, these methods are not mutually exclusive. And they can and are very often used together, and they can actually complement one another. So now that we've covered some of the general geometry modification and creation and discussed the two approaches for meshing on geometry, we're going to show you how to include additional pieces. An additional feature of the DTMB 5415 case is the inclusion of a bilge keel that's used for roll damping studies. So the bilge keel is provided as a separate file, so we'll append the bilge keel geometry to our existing project. So there are two things we need to do to the bilge keel before we add it to our model. The first step, like before, is to make a watertight model. So Travis, again, is going to use the model assembly tool, showing now, yes, we have a watertight model for the bilge keel. Now we would like to attach it to the hull and have it cut a hole in the hull surface to match the bilge keel edges. However, there's a slight gap existing between the bilge keel and the hull, so we're going to move it just a very small amount so that we can use it to cut a hole in the hull. And so Travis is just translating it, just a very small amount. So we're almost ready to trim the bilge keel on the hull models, but we need to do one more intermediate step that will help with the trimming operation. So models in Pointwise have the notion of orientation, meaning which direction is in and which direction is out. And so the red arrows denote the outward direction. So Travis is indicating this here where you can see all the normals are pointing outwards. And so we just verified the orientation of the hull, so the hull and the bilge keel models both point outwards. So now Travis can trim away the inside portions of the hull and the bilge keel. So by choosing a consistent model orientation previously, it made it easier for him to trim away the unwanted pieces. In this case, we didn't want the inner part of the hole in the hull, so he chose not to keep the inside. He unchecked keep inside. So the final step is to join together the two new models. So again, using the model assembly tool. And so now you can actually see the hole created in the hull from the surface trimming. And we're finished the watertight hull with the bilge keel. Again, we can see all the blue internal curves. So like before, when a mesh is placed on it, it's now automatically watertight. And Travis will just use the grid merge tool again just to confirm that. So we can see all our internal grid curves are blue. And another important point that we're just going to show really quickly is that any modifications we make to the mesh now, the mesh will remain on the model. So Travis is going to select the grid curves around the bilge keel and refine it a little bit because it's obviously way too coarse. Okay, so we're finished. So just a final recap. There are two general approaches to meshing in Pointwise. Fault-tolerant meshing, don't touch the sloppy CAD, fix the errors on the mesh level. Solid meshing, heal the sloppy CAD so meshes are automatically watertight. And remember, these methods are not mutually exclusive. You choose how and where you want to use them to best suit your needs. So that concludes our demonstration of some of the key techniques we used in Pointwise to clean up the DTMB 5415 Naval hull so that it's ready for meshing. At this point, we're going to open up the virtual floor to you so you can ask questions about what you've seen here or any other questions about Pointwise. Rick and myself will be fielding your questions.
So if you have a question you'd like to ask verbally, all your mics are muted right now. Use the hand raising function and I'll recognize you and you can ask whatever question you would like. So anybody have any questions? Okay, Arsenio Demanlig, do you have a question?
Yeah, I'm sorry I came in late on the seminar here, but I noticed that all of the surfaces that you have here, that you were just talking about gaps being like the problems on these types of surfaces. But what if, let's say, you have situations where you have like overlap surfaces, meaning like a certain section A is sort of falls in between, or sort of falls part of surface B, let's say, like there's like an overlap basically. Would that be able? Would you be able to handle something like that? I mean, is there a way or some sort of technique to handle a situation like that?
I think I can field this question, Rick.
Okay.
So, I'm going to answer this in two ways, Arsenio. Yeah, when I said overlap, when I said gaps before, I guess I just maybe meant that as just a general gaps and overlaps. If you have small differences between the surfaces, the mesh merging as well as the model assembly will take care of that. Now, the second way to answer that is like I did at the beginning. If the overlaps are so gross, like we had two surfaces that were grossly overlapping, In that case, you don't want to use the merging and the model assembly. You're going to want to actually modify the surface and trim it. So the first step, like I did, I split the overlapping surfaces because it was grossly overlapping. In the other cases, yeah, there was gaps, but there also could have been small overlaps. So those would be the approach that I would use for that case.
Okay, thank you.
All right, Darren Grove, you had a question? Darren, are you out there? Make sure I've got him unmuted here. Darren, did you have a question? All right, I'm having some trouble with Darren. All right, any more questions out there? All right, we've got a question from Ali Ben Madur. Go ahead. Ali? I wonder if the problem is on my end. Ali Ben Madur, if you have a question, you can go ahead. All right, apparently I'm not a very good operator of the mute and unmute here. I'm 1 for 3. Anyone else have a question? Okay, Mohammed Badr, go ahead.
Yes, I have a question about the slides you showed. The 2 techniques that you showed for fixing this problem on gaps and meshes, what are the pros on each technique, and what one do you prefer, like solid meshing or the other one?
So, Mohammed, I put back my last slide here. So just kind of, these are just my kind of general feelings as when they should be used. So the fault tolerant meshing, the pros are on the left-hand side. So, you know, if you're just doing one-offs, you just want to you get to the final mesh as quickly as possible, and you're not really concerned about fixing the geometry. It's good. That's a good approach for fault tolerant meshing. Fixing maybe just a couple of problems in your CAD, or sometimes there can be such difficulties in the CAD that it's just not possible to fix it on the geometry level. So again, you can use the fault tolerant meshing for that. Just mesh right over or in between the problems. Or, like I mentioned, you don't even need CAD to mesh. So that's kind of part and parcel with the fault tolerant meshing. If you're just doing, say, like I mentioned, for external flow problems where I'm just creating a box and I just have just some flat boundaries, I can just go right to the mesh and just create grid curves and create a surface mesh for that. Now, the solid meshing is kind of, you know, it's complementary. So where fault tolerant meshing is maybe not so good, solid meshing is better. So if you're going to mesh on a geometry many times, it's probably better to fix the geometry so you can, so you can revisit this geometry later for additional analysis. Or if you have lots of problems throughout the geometry, it's probably better to go ahead and try to heal up the geometry. Or in this case, in the hull case, I actually had to do some surface modifications and then make a solid from that. And then even further complement the solid meshing is that if you import an IGES file that has a solid in it, or your native CAD file, the solid most likely will be contained within that CAD model, and all the geometry cleanup is already done for you. You just can go right to a watertight surface mesh. And like I mentioned at this bottom of the slide, it's it's nice that you can use them both together. You don't have to pick or choose. You just flip-flop whatever one suits your needs.
Okay, thank you.
Yeah.
All right, let's go back and try Darren one more time. Darren, are you out there?
Yes, can you hear me now?
We got you now. Okay.
Yeah, it looks like the audio mode had to be switched to use telephone, plus I had to enter the audio pin. Anyhow, I was wondering that when you join 2 patch surfaces together, as you showed, you still, the connectors that the connectors kind of stay separate. I don't know if you can go back to the slide where you had the hull and you kind of joined that overlap. Well, once you trimmed everything up, you went into the model and you kind of joined 2 patches together and then meshed over them again, showing how the mesh crosses the boundary. Is there a way that you can choose to also connect the two connectors together, that basically you would merge connectors to get rid of, merge them into one, so to have two separate connectors?
Let me, I could see, Darren, if I can try to understand. Maybe correct me if I'm misunderstanding your question. So you're asking about you've made a solid model and then you put a mesh on it, but you're still having some gaps in between the connectors?
No. If you go back to, I don't know if you can go back to the slide where you show the mesh on once you created the solid model.
Okay. Actually, we did that live right in Pointwise, so just let me go to Pointwise.
Okay. So essentially, you modeled, you joined, and right there it was. If you just bring up that image you just had.
With the mesh on it, sorry.
With the mesh on it.
Mm-hmm.
Okay. So you remember in the center of the fuselage thing, the airplanes now, where you join that forward portion.
Okay, right about here.
There, yeah, right there. So you have, on the top you have a connector. It's basically two connectors. So when you join them surfaces and you want to mesh over them, it retain that connector. Is there a way that if you know that you want to join two surfaces, that you can also join just them two pieces into one connector in one step?
Yeah, absolutely.
Same with the bottom.
Yeah, you could. What you could do is just let me delete the mesh. I'll pick that model again. And that Travis was using just a quick shortcut, create a mesh on the geometry from the toolbar. The way to do that would be go into create on database entities. So for everyone out there, database is our term for geometry, and you could enter in connector join angle. So let's say it's just anything above this turning angle, it's going to join. So I'll just say 45 and let it do that, and then the resulting mesh will have joined connectors. So there we go.
Okay, perfect. Yep,
yeah.
That's what I was looking for.
Yeah, so that's just a little, that one's a little bit more, that's the menu version of it. Gives you a little bit more options, and so you can go ahead and have it kind of automatically clean up some of that extra entities for you.
Okay, great. Thank you.
No problem.
Okay, next let's go to Andy Lowe. Are you out there, Andy?
Hi, Chris. I had a question regarding the topology of the surfaces themselves. So it looks like we did a lot here with connectors, but what sort of advice do you give for geometry where you've got like ripples on a particular face or other sorts of faulty face topology?
So so within the internal definition of the surfaces, there's just some ripples that but you're not really wanting to resolve them.
Exactly.
I mean, in that case, I mean, when you, for example, let's just, hypothetically speaking, let's just say that this whole surface here had exactly what you're asking about. Let's say, I think it's this one right here. Oops. You could say this one right here. So we've meshed on that whole surface, and like you're asking, maybe there is some ripples in that. But remember, the mesh is discrete, so the resolution of the mesh may be such that it's larger than those ripples, and it's going to really technically just mesh right over top of them. For example, let's say the ripples were smaller than the edge length of the internal mesh. In that case, those would just disappear from it. The only way they would show up is if you created a mesh such that the edge length of that mesh was smaller than the actual feature itself, like in this case the ripples.
So the curvature refinement won't automatically detect those ripples and try to squeeze more cell in there. It'll probably just smooth right over it.
It may if you have those values set low enough that it picks it up. But generally you could set a value such that it would just ignore that and just not pick that up. For example, there's one in the defaults. There's under let's see, unstructured. So you can under the unstructured domains, which is domain is our word for surface mesh. You can set a minimum edge length so that it doesn't go below a certain criteria.
Okay.
Thanks for your question.
All right, let's next go to, I think it's Isaac Osser, or is it Isaac?
Hello? Hi there.
Hello?
We usually work with taking some faceted geometries or STL faceted triangular surfaces and trying to recombine them back with our original CAD. Is there any way that you had to smooth a faceted STL geometry?
Do you want to answer that one, Rick?
I'm sorry, I didn't hear the question. Can you repeat it?
Yes, we work with STL, faceted triangular surfaces sometimes. We want to take those surfaces and recombine them with a smooth CAD geometry. Is there any way that you have to take a faceted geometry from an STL file and smooth that surface?
There is. There's not a direct way to do it in Pointwise. What I would recommend in a case like that is to read in your STL file and then put a quad mesh on that. And the quad mesh then you can export from Pointwise and then re-import as geometry. And on that you can apply the smoothing tools. If you need to at that point, you can smooth it out using any of the smoothing tools in Pointwise.
Okay, thank you.
And just a quick add-on too, Isaac. You can mix and match analytic and STL files on Pointwise. You can keep appending, and you can append whatever format you want, and have just kind of a hybrid type geometry.
Right. Thanks.
Okay, let's next go to Maxwell Starr. Are you out there, Maxwell?
Yep. Hi, can you hear me?
Yes.
Hi, great. I've actually got a few questions I was wondering if I could ask. I'll try not to keep them too long. Firstly, I was wondering, when you added the keel onto the ship on the bottom, is it possible to add such a shape across multiple surfaces rather than the single surface you added it to?
Yes, the trimming operation would work across multiple surfaces, because in our speak, we're actually trimming the models together, and because we have a model for the bilge keel and we have a model for the hull, and those surfaces comprise each one of those models, we're really doing the trimming on the model level, so it can handle trimming across multiple surfaces. Yes.
Okay, great. And my next question is, you added the deck on the top of the hull, and you made that surface by selecting the other edges of the surfaces. If you wanted to make a surface on the far side of the model, as we're looking at it now, so on the symmetry plane, would it be possible to make that surface constrained to the edges that are there, but actually also constrained to the line of symmetry, so it's a straight line and not smoothed out by the software? That makes sense.
Okay, I'm not quite clear. Go ahead. Maybe just try to clarify it for me.
Yeah. Basically, if you took this model as it is now and you wanted to create the surface on the far side of the model, which is along the symmetry line, would it be created as a completely straight edge, surface, or would it actually smooth out the surface according to the edges that are already there?
So you're saying, like, you're thinking about, you're trying to maybe create a surface based on the curves on the symmetry plane?
Yeah, that's right.
Like,
so would it be a straight surface constrained by the symmetry line?
I believe so, because I'm pretty sure there would be, because if we look down, let's say we look down, so we're looking down the streamline direction, we can see all those curves lie in the XZ plane and the XZ plane for you. So yes, if you could go ahead and create, it would create a flat surface based on those.
But if the model we had wasn't completely, if some of the lines went past the XZ line, would it be possible to trim those edges so that it would then create a straight line, a straight edge down there?
Yeah, yes, I believe so. Again, maybe I think I'm just not quite understanding what you're trying to get at. So, re-ask your second part of your question again.
Well, as you just showed, that where the XY, it was straight edge down the symmetry line. If that didn't happen, if there was, say, a plane that came out a bit too far somewhere, and you wanted it to be a straight edge, could you actually create would you create a plane and then trim based on that plane out to create a solid, straight plane?
Yeah, you definitely could. That could be one approach. Yeah, absolutely, you could.
Okay. And my final question was, one of the questions that was asked on the text questions was about file types that can be imported. And they talked about Pro, E, and SolidWorks. Will Rhino be possible for import as well? Because Rhino has some ship whole capabilities already.
Yeah, as far as I know, there's, nothing direct, like not the Rhino file format. I haven't used Rhino a lot myself. All I can say that I believe that its IGES capabilities are pretty good. I think it generates very good IGES files, and we have a very robust IGES import. So I think that would probably be the optimal path between Rhino and Pointwise.
Okay, that's fantastic. Thanks very much.
Absolutely.
All right, let's go back to Ali Ben Madour again and try him. Oops, I seem to be having trouble unmuting him. All right, I'm having some trouble there, Ali. I can't unmute you for some reason, so let's move on to Onur Dur, O-N-U-R-D-U-R. You out there?
Yes, Onur. Hello.
Thanks.
I have a couple questions, if you don't mind. First one is, after you apply the geometry healing and filling the gaps, those type of operations, are you still able to subtract new volumes or new surfaces from the modified or healed geometries? Do you have any troubles with that? Many of the commercial softwares don't really allow the split or subtract operations.
Yeah, there shouldn't be any problem. This is a little bit similar to the question that Maxwell Starr just asked, excuse me, where if I have multiple surfaces in this model, can I cut a hole or can I trim across multiple surfaces? And that's perfectly fine, because it's most of these operations are done on the model level, and they work optimally on the model level.
Okay, great. The second question is about journal files. Do you have a journal file after the operation? Can we actually save our operations and modify them without using the user interface? Is there a batch mode to use this software?
There is. Yeah, that's a very good question. There is. You can see here, I'll just put up, there's a script menu, so we call it scripting. And there's also a journaling option where you can begin journaling, and basically it's just recording your commands as you're doing operations, and then it will save it as a text file. And maybe I'll just take the opportunity to just mention a little bit about the scripting language in Pointwise. It's called Glyph, and Glyph is really just an extension of the interpreted programming language called TICO, TCO. So really, we're just adding functions to TICO, and so you can journal all those Glyph commands and those TICO commands, and then you can use it to either replay something you did before, or you can write scripts from scratch. And Pointwise can be run purely in batch mode, or you can run these scripts in GUI mode. It's up to you. It's a very flexible, very extensible method of doing scripting.
Sounds great. And my last question. One second. I guess I'm fine with the questions. Thank you so much.
Okay, thanks for your question.
All right, let me try this one more time and see if I can get it correct this time. We'll go back to Ali Ben Madour now. Are you out there, Ali?
Yes, I'm here. Can you hear me?
Yeah, we got you now. Good.
Okay, that's good. Actually, the problem was at my end. Yeah, I had to enter a code on my phone pad to connect to audio, which I didn't. Anyways, yeah, a couple of questions here. First, is there a plan to include step in the to read the geometry in Pointwise? Right now, I think it reads only IGES.
Rick, do you want to clarify that situation?
Yeah, I'll talk about that. Yeah, currently in Pointwise version 16.04, which is our current release, the main way to import geometry is through IGES. We're currently working on the next version, which will come out sometime in 2011, that will incorporate native CAD readers, and that'll be part of the standard product, which is a little bit different than in GridGen, where they were an add-on additional cost product. So when the next version of Pointwise comes out, we'll have native CAD readers for all of the different CAD types that we currently support in GridGen, which is CATIA V4 and V5, Pro-E, NX, and STEP. And then we'll also be adding support for SolidWorks and for ACES SAT files, and seems like there's one, Parasolid is the other one. So you can look for that to be coming out in the next release of Pointwise. For the time being, you have to use IGES to read in the geometries.
Okay, but STEP is not a native CAD. It's like IGES. It's
right. It's like IGES. We refer to it as native CAD in our current product in GridGen because we use IGES as our native format. Our native format. All the other ones we consider external.
Good. Thanks. The other question is related to the webinar. I was just wondering how big would the gaps be to use the two methods to fix them?
That's probably up to you, but I mean a rule of thumb is you're probably not going to want to heal a gap that's, I would say, you don't want to heal gaps definitely larger than your mesh level. So, definitely just a fraction, maybe your overall model size. In this case, the model size, the length is about 2, and our gaps were, 4 orders of magnitude smaller. So, I guess really so much just a visual thing, really, like I said before, the modeling assembly, so the solid models, it's not modifying the surface, it's just kind of creating the glue across the gaps. And so, the larger you start making that glue across the gaps, you start getting unwanted and unwanted behavior. So really, it's just for, just general sloppiness, not for actually fixing missing geometry. If there's fixing or like grossly overlapping geometry, you're probably going to need to fix it, like I did with the overlap surfaces. But if there's just a general sloppiness, and those errors tend to be on, and like I said, on the order of several magnitudes lower than the overall model size, those are appropriate for healing up with the model assembly and the mesh merging.
Okay, thank you. Thanks.
Thank you. All right, let's go to Nisander Risky.
Hello, can you hear me?
We have you, yes.
Okay, I have a question about tolerance. How do we know how big is the value for the tolerance? And is there any ballpark number for the tolerance?
That's a good question, Sandra. Something that Travis we kind of showed at the beginning is when we started out with the original surfaces before we healed them up with the model assembly is there is a tool. Actually, I think I can even go back to maybe the original geometry. Oh, this one's already been healed up. Let me step backwards a little bit. Yeah, we've already kind of gone past this part. But what you would do in the center is you would use these surfaces. You would select the geometry surfaces, excuse me, that you want to interrogate. You want to look for. You want to look for the gaps in, and under the examine menu, which is where you can interrogate meshes or geometry surfaces. There's a tool called boundary proximity. And what the boundary proximity is doing is looking for the distance between the internal points on the geometry surface and the adjacent surface. So in this case here, this is the surface patch that I'd modified originally, and so I'm highlighting the curves between those two surfaces, and it's actually indicating the value on that color bar. If you see towards the bottom, I have my cursor is highlighted over a geometry point. And towards the bottom of that color bar, it has a value. It says 0.000187, etc. And that's where I go to kind of give me a general feel for what my gap size should be. And so then when I go to enter in a tolerance value, I want to set a value a little bit larger than that. You don't want to get, you don't want it to be 2 orders of magnitude larger, just enough to close up the gap. Otherwise, again, similar to the last question, you'll get kind of unwanted results. You just want to use a tolerance that's slightly larger than the gaps in your model.
Okay, sorry.
Okay. All right. Yeah, that's all for my question. Thank you so much.
All right, thank you. All right, let's go back to Honor Dur again. I think he has another question.
Hello, thanks for the second opportunity. I forgot the question last time. So how do you manage the mesh size, the grid size, if you want to make a non-uniform grid with some refinement on the leading edge versus some coarse on the bottom? Do you have boundary layers or size functions embedded in the software?
Yeah. So what we were showing today was just some basic meshing approaches because we're really focusing on the geometry, but that's a good question. So the general approach with our software, Pointwise, is to, in this case, I actually have the default panel open in Pointwise. So what we do is we just say we're going to set an average spacing, or if you want, you can fix the number of points that are going to show up on the grid curves. And there's some more advanced parameters below, but for the most part, you just, as a first step, you go ahead and you fix your geometry, or maybe you don't fix it, you use the fault tolerant approach, but you put a mesh on your geometry, and generally as a first pass, it's going to be relatively uniform. Again, there are some advanced tools for creating more uniform meshes, maybe based on curvature or something like that. Kind of similar to the question that Andy Liu was asking me before. But, and then once you get a mesh on, the idea is to be able to get a mesh on very quickly. And then once you get a mesh on it, then we go back to, at that point, we can select the grid curves and modify it. So like Travis had showed at the very end, was that, well, clearly the mesh resolution, the default mesh resolution is like grossly too coarse for the bilge keel. And so we selected the grid curves on the bilge keel, and then he used one of the tools for changing the resolution on those grid curves. And here he said, well, I want an average delta S, you know, an order of magnitude smaller. And so he just clicked the dimension, and it will, you know, refine the grid points on those grid curves, and then update the surface mesh accordingly. So the general approach is to, you know, Pointwise uses the bottom-up paradigm where you start with grid curves, you go to surface meshes, then you go to volume meshes. Now this modeling approach is kind of nice because it kind of allows you to skip having to create the grid curves first. It does the surfaces and the grid curves, surface meshes and the grid curves simultaneously. You modify your grid curves till you're satisfied with the resolution, and you create a volume mesh, you know, as the last step. And there's similar sort of controls for controlling and refining the volume mesh as well.
Okay, thank you so much.
So.
And
yeah, so like again, I can even just show I'll get out of this panel, and it's telling me right now I'm hovering over the curve on the bow of the hull, and at the very bottom, kind of right, it tells me there's 35 points in that grid curve. So I'm just going to go and I want 55 grid points, and it will automatically do that, and it will refine the mesh as you need it. So there's a variety of tools you know, built in for doing that. And if you have you know, if you have some more questions about that, send me an email, and I can give you some more examples or try to clarify that for you.
Thank you so much.
No problem.
And the meshes are compatible with ANSYS products or commercial solvers. That might be the last one.
Yeah, that's a very good question. So essentially, Pointwise is kind of a solver agnostic meshing tool or pre-processing tool, and then when you're done with your mesh and you're ready to you want to save it in your solver's format. You choose that you choose what solver you're working with under the CAE menu, and so you can see here's a list of our supported products, and those ANSYS Fluent, ANSYS CFX, STAR, the products from CD DACO, STAR CCM, STAR CD. There's a whole list of, you know, commercial as well as government and a variety. And I should also note that if you're using a custom solver and has its own, you know, grid format. We even include an API to this CAE menu here where you can actually write your own grid exporter and have that solver type show up on the menu, so you can set boundary conditions and whatever you want.
Oh, that's fantastic. Thank you so much again.
Yeah, absolutely.
All right, let's go now to Ushio Yuki. You have a question?
Yes. I had actually typed a question in before, but I want to ask a follow-up about cutting the hull, cutting the model on the hull. I was curious when you cut, and then sometime later on, you know, long after undo is not possible, you decide that you want to recut the model in a different way. And is there a best practice on how to do that? Because I seem to remember one time I tried doing this, and I ended up with a bunch of extra models that I don't know, it wasn't very clean in how I did it.
Mm-hmm. So your question is you cut a model, and then later on you really just want to maybe modify the location of that cut?
Right.
And
okay. I think what I did was, like, I deleted one of the models, and then I had like a model that had a bad cut, and then I made another cut, and so I had like an old model with a bad cut and a new model with a correct cut, and I was just wondering if there was a cleaner way, or what's the best way to like redo it and not have extra surfaces and models lying around.
Rick, do you wanna give a shot at that one?
Yeah, I think the important thing to note there is that when you're doing these cuts, that the original underlying surface is still there. This is just making a trimmed surface with for in this case of the bilge keel that we looked at today. It's just looking at the intersection between those two and creating a trimmed surface on top of that original hull surface. So say I had a different bilge keel location, the first thing I would do is to remove the existing trimming curves with the old location, and then I would re-intersect the new bilge keel location with that model that's essentially doesn't have the hole cut in anymore, and then just basically repeat the process. So you can undo this process even though you may have gotten out of Pointwise and gotten back in, so the undo command doesn't work. But you can remove the hole just by removing the trimming curves, and the underlying surface will still be there. Does that help?
I see. So you can modify the cut and remove the cut.
Yeah, you can remove the existing cut and then make a new one and put it on there, because there's the underlying surface, that hull surface without the hole, is still there. It's hidden right now, and there's just a trim surface that's built on top of it that has the hole cut out of it.
Okay, that helps.
So yes, I think what he's kind of saying is that there's kind of a new surface, a new trim surface put there that's got the hole cut in it. So the original underlying surface is still there. So you could return to that and then do some other sort of operation on it.
Okay, that helps. I appreciate it.
Okay,
yeah.
Thanks. All right, and I think Arsenio had another question. So Arsenio, are you still there?
Yes.
Okay.
Yes. We do a lot of parametric studies where I'm at, and this is where we port in geometries where, let's say, a certain part of the surface would be different. Like if it's like a wing body case, then maybe a longer wing or a longer span wing or different shape airfoil. And I was just wondering, with both these methodologies that you just discussed today, how would those be optimally used for let's say a parametric study like that? I mean, because there are cases where I would just like to have the same kind of gridding process on one geometry and then just transfer it over to another one that has a slightly different surface. So
yeah, that's a very good question, Arsenio. So yeah, since you were specifically asking for just like you do maybe some optimization or some parametric study of just slight deformations, maybe say in the shape of a wing, that's perfectly fine. You could in that case you'd actually want to reuse the mesh and then import your new geometry every time. And then what you would do in that case is you would import the new geometry, import the original mesh, and then there are tools for reprojecting the old mesh onto the new surface. And so there's a tool here, we already have it by default on the toolbar. It's called Project, and Project is specifically doing that. So in this case, because we have a one-to-one correspondence between the geometry and the mesh, it's telling me that all the mesh points are on the surface. In your case, when you imported that new geometry in, all the points are going to be off, but you can use this project operation to reconstrain it. So it would kind of follow the deformations that you're encountering every time you generate a new geometry. Now the only thing I definitely want to clarify is that if the modifications to the geometry are going to be kind of less than slight and bordering on gross deformations, at that point you're going to have to be careful, because maybe the grid topology that's in your old grid is no longer going to match the topology in your new geometry. So, but definitely in your case, if you're just doing slight parametric or optimization type modifications, then you can just reuse the old mesh and reproject it onto the new geometry.
So projection would be a part of your line of your whole process then. I mean, because I'm thinking if you're going to be importing another geometry, especially if you're like using the script function, I mean, would having project reproject be helpful in, let's say, in being part of your script, your glyph script?
Yeah, absolutely. That is like a perfect example of how you could use the glyph scripting. Is you've generated a geometry once, you've created a surface mesh on, you've created a mesh on it, a full mesh, and you're happy with it. Now you're saying, well, I'm gonna go and create 100 different geometries that have some slight changes in the wing shape. I don't want to have to remesh, so I'm going to write a script that's going to read in the new geometry, read in the old mesh, and then reproject the mesh onto that new geometry, save out my solver file, and it can do that all in batch mode in the background.
Okay, but just to be perfectly clear, though, I mean, this is you're doing the reproject just because the surface, because sometimes when I do this, I would read in the same database file that has a slightly different surface A, okay, compared to the original geometry, and what I would hope is that, you know, the grid file would automatically be projected onto that. But what you're saying is that it has, if it's slightly changed, or if it's even in a different order in the way the database entities are listed, then definitely you have to go through like some sort of a glyph script to sort of do a quick regrid of that new geometry.
Yeah, let me clarify that a little bit more, since I think you have a pretty specific use of that. So the way Pointwise is going to work is that it works on names. The surface meshes are looking for the names of the geometry surfaces.
Yes.
So in this case, we have a hull surface mesh, and it's going to be attached to, say, hull surface 2. Now, even if they came in a different order, if the new geometry has the same names, Pointwise is going to know to snap those meshes onto the geometry. Even though it's modified, it's looking for the name. Now if those names change, so what's going to happen is the Pointwise is going to read in and say, oh, I can't find my corresponding surface to snap to. That's okay. I'll just be unconstrained, and at that point, it'll be up to you, the user, to either do it in the GUI or do it in the script to reproject the surface meshes onto the geometry.
Okay. Okay. But I'm sorry. Can you? So the ordering shouldn't matter, but the naming does. Is that right?
I believe so. Rick, am I correct in that understanding?
Yeah, the one place where the order might make a difference is if you're reading in entities from an IGES file and they don't have the IGES name entity, so they're not named, then they'll get a default name when they're imported that depends on the order that they come in. So in that specific case, if you're reading in geometry that doesn't already have names, the names will be dependent upon the order that they're read.
Okay, and in terms of healing the surfaces, if let's say every geometry that I read in needs a healed surface, would you rather go the solid mesh way, or I mean, would that be the perfect? I mean, in your opinion, would that be a perfect way of getting around that, or I mean, because you did discuss both the methodologies. So.
Yeah, that's a good that's a good thing to bring up. You're right. I mean, if you're again, this is assuming you're doing this in batch mode. If you're let's say you had a process you'd done it manually in the GUI once, and you had a pretty reliable process for making a solid from your IGES file to fix all those gaps, and of course you could name that model, and then you could re-import, you could redo the same process and bring that surface mesh on. Now but I believe it's going to be based on the names, but you'll have, in that case, you'll actually have control of the names, because you could actually go ahead and name them. This actually kind of leads back to my pro about doing the solid modeling, is that when you're reusing the geometry many times, is you can create that model, you can actually give it a name to Pointwise, and then also all the subsequent quilts within that model, you can also give them names, and so you could go ahead and then redo that process and reuse all those names, and then again Pointwise would should snap to those quilts and those models.
Okay, and just one more off webinar question here. Will there be, when will you be able to include anisotropic grid generation, or is that included already in the new version of Pointwise, or the latest version of Pointwise?
Rick, did you want to answer that one?
The current release of Pointwise, 1604, has the 2D anisotropic meshing, so you can make T-Rex grids on surfaces with the current release, and we're working on the 3D anisotropic meshing for the next release of Pointwise. We're pretty early in the planning process on that one, so I don't have an exact release date for that. Our goal is to get it out in 2011, and the sooner the better. But once we get far enough along to have an estimated release date, we'll let you know. But that is planned for the next version of Pointwise.
When you mean 2D, you mean just like a 2D plane, or 2D on like on the surface?
On surfaces too.
Okay. Oh, okay. Thank you so much.
Thank you.
Yeah.
We're over our allotted time. We've got a few more questions, so we'll see if we can get through them pretty quickly. So next, let's go to AJ Piplica. You there, AJ?
Hey there, you guys hear us?
We got you.
Okay. Two quick questions. The first, back when you guys were talking about the native CAD readers that'll be coming out in the next version, was Solid Edge one of those? I heard SolidWorks.
Solid Edge is not one of the specific types that we have. You'll have to help me out a little bit here. I think, isn't Solid Edge based on Parasolid?
I believe so, too.
So you most likely will be able to write out
I think we can export Parasolid.
Yeah, if you write out a Parasolid file, you'll be able to read that into Pointwise.
Okay. All right. And the other question, I'm not sure if you guys will be able to answer this. On the IGES naming, since we're using Solid Edge here, IGES is usually the file type that we move things over in. What do you guys know about naming things in an IGES file?
I know there is a name that you can assign in IGES. How that name gets into the IGES from the CAD system is going to be dependent on the CAD system that you're using. And I'm not familiar with Solid Edge, so I can't help much there. Do you have any idea, Chris?
No, I don't. And maybe that's a question that you could contact our support. They might be a little bit more familiar with the answer to that.
Okay, great. Thank you very much.
Thank you. All right, let's go to Arash Eslamboost.
Yeah, hi there.
Hello.
My question is about growing prism layers on on top of surface mesh. Sometimes it happens to me that in sharp corners, when I try to grow these prism layers, the surface after multiple layers, let's say 5, 6 layers, depending on the geometry, doesn't appear smooth anymore and become jagged and eventually crashes. Is there any opportunity to fix this?
I can probably answer that in two parts, Arash. One, it's just the algorithm itself, the standard prism extrusion method that's available not only in Pointwise but lots of other different preprocessors. That algorithm inherently is to march really layers of the it's really just almost like a duplicate of the original triangulated surface mesh, and march out layers, and and like you said, when you encounter sharp corners, you have adjacent points colliding, and all sorts of difficulties arise, and you end up with this very ragged-looking front. It's just a deficiency of that algorithm in general. Not necessarily something about Pointwise. Now there are some tools, smoothing tools and stuff in the Pointwise prism extrusion technique to kind of try to mitigate and steer around that. But ultimately, it's just there's only so much you can do with the prism extrusion. Now, the question just a couple of questions ago was asking about the anisotropic tetrahedral extrusion. That's specifically what that method addresses. And the idea with the TET extrusion method is that instead of using prisms, we're going to use TETs to create layers of high acidic ratio right-angle cells in the boundary layer. And that method is very, very flexible in the fact that when it encounters a difficulty like a collision in a sharp corner, or even if you have adjacent fronts that are going to collide, this method can actually stop the cells just locally, only where it has to, and continue growing elsewhere. And then as a second step, when you're done using that technique, as a second step, you can tell Pointwise to recombine the TETs into prisms, so you kind of get the flexibility of the 100% TET approach, get your boundary layer resolved meshes on your very complex geometry, and then you can use the prism, prism recombination is what we call it, the prism recombination algorithm. Now, again, just to reiterate the last question, is that method in 3D is not in Pointwise. It's in our legacy product GridGen, and if you have a current license of our software, you have access to GridGen. So just to kind of give you an idea, is that you could do pretty much everything you want in terms of surface meshing, geometry cleanup, and Pointwise, and then you could do that use that 3D technique. It's just a volume meshing algorithm. You could take that grid and put it into GridGen, and then go from there.
Okay, thank you.
Yeah.
Thank you. Okay, one last question then from Nisander Risky.
Hi, I have a question about actually there are two quick questions. One is the advantage of fault-tolerant meshing. You mentioned it is good for one-offs. What do you mean by one-offs?
Well, I mean, because with the fault-tolerant meshing, you just don't worry about the CAD. You don't spend any time on the CAD at all, or very little. You just really have to fix the gross errors. You just leave the gaps and the cracks. You go right to the meshing. I mean, ultimately, what you're trying to do is you're trying to mesh. So it's like, let's just ignore the CAD. Let's ignore the sloppiness in the CAD. Let's get to the mesh, and then fix the mesh. Now that process, you can imagine if you have multiple cases and you have to go, and then ultimately you have to go through the cleanup process at some point. You have to do it on the CAD level or the geometry level, or excuse me, on the CAD level or the mesh level. So if you're just going to do a one-off, you can just go ahead and just do it on the mesh level and be done with it. Now if you're going to use that geometry over and over in subsequent analysis, it's probably a benefit to clean things up on the geometry level, save that geometry cleaned up, and then future time, every time you return to it, it's already fixed and it's watertight, and you just go ahead and mesh it.
Okay, and another question. How do you pull out that symmetric plane?
So how do we create it?
Yeah.
Yeah, under the create tool, there's a plane option, and there's a variety of tools for doing that. You can make a constant X, a constant Y, a constant Z, and then there's a variety of other plane modes if you want to get a little bit more complicated. So in that case, Travis did just a constant Y.
Okay, thank you.
Thank you.
All right, I think that's, oops, I'm sorry, I see one more question. Back to AJ again one more time.
Hey, when you're using the merge utility, is there a way to tell it not to look at different layers? Because when you turn it on, no matter what layers you have on or off, it's still, the numbers at least, seems to go over the entirety of what you have in your Pointwise file.
You want to clarify that question, Rick?
Yeah, actually, I don't know of a way to turn that off. It assumes that you're interested in the way those grids are connected, whether their layer is on or off. So I guess I don't know the answer to that. Sounds like, Chris, you don't know either if you can turn off to have it not check grids that are in layers that are turned off.
Yeah, I don't believe so. I think yeah, AJ's observation is right. I think it's checking all the curves, whether they're in their layer or not.
Okay.
So
maybe I'll request.
Okay, thanks, AJ.
No problem.
All right, thank you. Okay, I think that wraps up things for today. Appreciate everybody's attention. Thank you for coming, and keep an eye on our website for upcoming webinars, and we'll let you know what we have planned. Thanks for attending today's webinar.